Jai Hind students, welcome to my YouTube channel. Students, never blame anyone in your life. I repeat, never ever blame anyone in your life. Good people will certainly give you happiness. Bad people will give you experience. Worst people will give you lesson. And the best people, they will give you memories. So what I mean to say is that, students, whether you are surrounded by good people, best people or worst people, they are always bound to give you something. So have that positivity in your life. Right, students? So let's begin today's session. Today we'll be discussing a very interesting topic of Archimedes Principle. It is about law of flotation of bodies. After dealing with this particular topic, we'll be able to answer some very basic questions. Why a pin, a nail sinks in water, but a ship, it doesn't? Why a body floats while some other body sinks? So we'll try to find out the reason for that. After the completion of this session, you will be in a position to answer all these queries. Right? So let's begin with the topic of upthrust or buoyancy, which we have done in the previous lecture. So let me repeat the concept of buoyancy. Students, you are aware, whenever a body is partially or completely immersed in a fluid means liquid or gas, then what happens is the fluid exerts on the body a net upward force. This upward force exerted by the fluid on the body is known as upthrust, or it is also known as buoyant force. And the property of the fluid, by virtue of which they exert an upward force on the body which is immersed in it, that is known as buoyancy. Right? And we have also in the previous lecture discussed the cause of buoyancy. The buoyancy can be explained, or rather the reason for the existence of buoyant force is on account of the pressure difference between the top and the lower face of a body which is submerged inside a liquid. So that's the cause of buoyancy. Right? So what we have discussed regarding buoyant forces, the buoyant force, it is also known as, it can be written as FB, or it is also known as upthrust, upward force. It is also known as upthrust. It can be represented by capital letter U. And we have discussed in the previous session that the buoyant force or the upthrust which the fluid exerts on the body which is immersed in it in the upward direction is given by weight of the liquid or fluid displaced by the submerged portion of the body. In case the body is entirely immersed in the body, then upthrust would be equal to the weight of the fluid displaced by the submerged portion of the body, which in this case would be the entire body. Right? So let us further rearrange it. We have discussed it. Okay, this is upthrust or buoyant force. Weight of the liquid displaced. Weight, it is equal to mass into acceleration due to gravity. So weight of the liquid displaced would be equal to mass of the liquid displaced multiplied by acceleration due to gravity. Now weight, as we are aware, it's equal to m into g. Right? So we are aware of this formula. Weight is equal to m into g. W is the weight of the liquid displaced. So mg, m is the mass of the liquid displaced, and g is the acceleration due to gravity. Right? Now mass, students, we are aware it is volume multiplied by density. We are aware mass is equal to volume multiplied by density. This is rho, that's density. So in place of mass of the liquid displaced, we can write volume of liquid displaced multiplied by density of the liquid displaced multiplied by small g. Clear, students? Now again, we have discussed in the previous session with absolute clarity that the volume of the liquid displaced would be equal to the volume of the body that is immersed inside the liquid. Clear? Whenever a body is immersed in a liquid, then it will displace some liquid. So the volume of the liquid displaced would be exactly equal to the volume of the submerged portion of the body. So actually volume of the liquid displaced would be equal to the volume of the submerged portion of the body. Multiplied by, this is density, this is obviously density of the liquid in which the body is immersed, multiplied by acceleration due to gravity. So this is upthrust or the buoyant force. Please do remember it. And we have discussed some numericals also based on buoyant force, isn't it? So basically, buoyant force or the upward force which the fluid exerts on the body in the upward direction, it depends upon upthrust. It depends on first volume of the liquid displaced. Volume of the liquid displaced. More the volume of the liquid displaced, more will be the upward force. More will be the upthrust or the buoyant force, right? And as I told you, volume of the liquid displaced is equal to the volume of the submerged portion of the body inside the liquid, right? And second is, it also depends upon the density of the liquid. It also depends upon the density of the liquid. So more denser the liquid is, more will be the upthrust or upward force exerted by that denser liquid on the body which is immersed in it. Clear? So students, again I repeat, because before we start dealing with Archimedes principle, you should be thorough with the concept of upthrust or buoyancy. Then only you will be able to understand Archimedes principle correctly, right? So upthrust is the net upward force which a fluid exerts on the body in the upward direction. And upthrust is also known as buoyant force. And this phenomena or this property of the fluid by virtue of which it exerts an upward force on the body immersed on it is known as buoyancy. And how to measure upthrust? Upthrust, experimentally or mathematically, it can be verified that upthrust is equal to the weight of the fluid displaced by the submerged portion of the body inside the fluid. Right? So upthrust depends on two factors. The volume of the body or the volume of the liquid that get displaced, right, which is equal to the volume of the submerged portion of the body. And second is, it depends upon the density of the fluid in which the body is immersed. So these are the two factors on which the upthrust depends. Now students, before I proceed with the Archimedes principle, its statement, the essence of Archimedes principle, I would like to watch this short animation, and I will recommend you to watch this entire lecture till the very end so as to understand the concepts, right? So do watch this short animation and then we'll continue this lecture.
Let us consider you have a beaker filled with water and you put your index finger inside it. You will observe that the water level rises slightly. And if you put two fingers, then the water level rises a bit more. And now, when you put your hand, then you will see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this though in mind. We will come back to it soon. In our previous lectures, we have seen that when an object is placed in or on the fluid, then the fluid exerts an upward force which is known as the buoyant force. The Archimedes principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the fluid displaced by the submerged portion of the body. We can take a simple example to understand this. Let us take a 5 kg of body and suspend it by a spring balance. The balance will read 5 kilograms. Let this be case 1. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is. And we keep a small container under the opening. Now slowly lower the solid object into the water and you will see that the reading will be a lower number as compared to the previous case. Why is that? It is because, students, of the buoyant force acting on the object. You did have noticed that some water was displaced. Now in this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That is the Archimedes principle. Therefore, the statement of Archimedes principle is when an object is partially or fully immersed in a fluid, then it experiences an upward force which is equal to the weight of the fluid displaced by the submerged portion of the body. Where is this principle applied? Can you think of some examples? How do you think large steel ships float? It's simple. If the weight of the water displaced by the vessel below the keel is equivalent to the vessel's weight, then everything above the keel will remain afloat. And that's one of the very important application of Archimedes principle. It is because of the upward force which the fluid exerts on the body floating over it.
Okay, students. Now, after watching this animation, let's recap the entire thing which you have studied, right? Okay. Let us consider a body. This is a body. And first point is, let us consider the weight of the body. The weight of the body in air or in vacuum. Vacuum means in the absence of any medium, that is free space, is W1. So it will act along this direction. So W1 is, students, the weight of the body under consideration. It is actually the force of gravity. Clear? It is equal to m into g. And remember, the weight of a body in free space where there is no medium is maximum. So weight of the body, this is a crucial point, weight of a body in free space. Free space means vacuum, in the absence of any medium, is maximum. Always remember this. Why the weight of a body in free space or in the absence of any medium is maximum? Any idea? Yes, you have assumed it correctly. The answer is, in case a body is in medium, then the medium will exert an upward force on that body, due to which the body will lose in weight. So in case the body is placed in free space where there is no medium, then the only force acting on it would be its weight, that is the force of gravity. So students, always remember, the weight of a body in free space, in vacuum, or you can consider in air, is maximum. And let us consider it to be W1, right? Second, when the body is immersed in a liquid, when a body is immersed in a liquid, then let its weight be W2. Now consider this case, the same body. Now it is assumed to be immersed in a liquid. Suppose this is the liquid under consideration. This is the liquid. So in this case, the weight of the body is W2. W1 is the weight of the body in free space or vacuum. W2 is the weight of the same body in a liquid or a fluid. Now we are aware, students, whenever this body is immersed in a fluid, then this fluid will exert an upward force on the body, and that upward force, it is known as upthrust, or it is known as buoyant force. Clear, students? And actual weight due to gravity, it is W1. So on immersing this body into a fluid, inside a fluid, it experiences an additional upthrust, upward force. So obviously these two are of opposing nature, they are oppositely directed, isn't it? So the net weight or the apparent weight of the body in the liquid will get decreased. So it will be given by W1 minus U. We have done some numericals also based on it. Suppose, for example, the weight of this body in vacuum or free space is 10 Newton. Suppose when the same body is immersed in a liquid, it experiences, or the liquid or the fluid exerts an upward force, that is upthrust, of magnitude 2 Newton. 10 Newton is its actual weight and 2 Newton is the buoyant or upthrust. So what will be its weight in the liquid? It will be 10 minus 2, that will be 8 Newton. It will get reduced, so that is what I have written over here, right? So the weight of the body inside a liquid is given by the difference in the weight of the body in vacuum and the upthrust or the buoyant force, right? Therefore, students, third important point, the loss in weight of the body inside the fluid is loss in weight through how much the weight of the body is decreasing. That will be W1 minus W2. Earlier it was W1 in air or vacuum. Now inside liquid its weight has become W2. So what is the loss in weight? W1 minus W2. So loss in weight would be W1 minus W2. This is the loss in weight. And W1 minus W2, it will be equal to U. Simply rearrange the terms. What do we get? U can come over here and W1 minus W2. This is the loss in weight of the body. Clear, students? Okay. Therefore, W1 minus W2. Let me write the statement now. Right? W1 minus W2 is loss in weight of the body inside the liquid or fluid. It is equal to upthrust. It is equal to upthrust, which is also known as buoyant force. It is also known as buoyant force. And students, upthrust, we have done it in detail. Upthrust is equal to the weight of the liquid or fluid displaced by the submerged portion of the body. By the submerged portion of the body. So students, this is actually the statement of Archimedes Principle. This is the main statement. I'll explain it again. actual statement of Archimedes Principle. So again I repeat, students, please concentrate, right? The weight of any body in air or vacuum or free space is maximum. We have denoted it by W1. Whenever the same body is immersed in some liquid, then the liquid will exert on the body an upward force, that is known as upthrust or buoyant force. Due to this upward force, the net weight of the body inside the liquid will get decreased, and the apparent weight of the body inside liquid would be given by W1 minus U. Therefore, W1 minus W2 would be equal to U. And what does W1 minus W2 signify? It signifies the loss in weight of the body inside the liquid. So, this is the statement, W1 minus W2 equals to U. So, students, Archimedes Principle, this is the statement. I'll repeat it. According to Archimedes Principle, it states that whenever a body is partially or completely immersed inside a liquid, then the loss in weight of the body inside the liquid is equal to the upthrust, which in turn is equal to the weight of the liquid displaced by the submerged portion of the body. So this is the statement of Archimedes Principle. Clear, students? Again I repeat, Archimedes Principle states that when a body is partially or completely immersed inside a liquid, then the liquid exerts on the body an upward force, as a result of which the body loses in weight, and the loss in weight of the body is equal to the upthrust, which is equal to the weight of the liquid displaced by the submerged portion of the body. So I hope now you will be easily able to remember the exact statement of Archimedes Principle. Am I clear, students? So we are over with statement of Archimedes Principle. So students, now let's discuss the condition for flotation of body. That is, we'll try to find out the conditions under which a body can sink or a body may float on the surface of a liquid, right? For that, you need to understand that whenever a body is immersed in a fluid, it is under the action of two forces. These are the two forces. Suppose this is a body and it is totally submerged inside a fluid, inside a liquid. Now, it will be under the influence of two forces. One is the force of gravity, which is the weight of the body, which always acts in the downward direction. So, let us consider it to be W. This is the weight of the body, which is also known as the force of gravity acting downwards. The other is, student, concept of buoyancy. This body is immersed in this fluid, therefore the fluid will exert on the body an upward force, that is known as upthrust or buoyant force. So it acts in the upward direction like this. It acts in the upward direction. This is also known as the buoyant force or upthrust. So whenever a body is immersed inside a fluid, liquid or gas, it is under the action of these two forces. Both are oppositely directed. Now, it's a common sense, students. Simple. If W is greater than U, then the body will go down. If U is greater than W, then body will move in the upward direction. And in case U is equal to W, then it will become stable at that position. Isn't it? It's a common sense. So this is how we can predict whether a body will sink or it will float. So basically there are two cases. We'll discuss it in detail. First case is when the body is not hollow from inside. We are considering solid bodies. How to determine whether this solid body will sink or this solid body will float? So we are not dealing with hollow bodies, remember, we are dealing with solid bodies. So those bodies which are not hollow from inside. So there can be three cases. This is the liquid. The body can either sink. The body can either sink. This is the first case where the body completely sinks inside the liquid. The body can completely sink inside the liquid. The second scenario, the body can float. with a small portion of the body remaining in air. This is the case. This is the second case. And the third case is, it can be like this. It can remain at equilibrium while fully submerged like this. This is another case. So students, these are the three possible cases. We'll discuss it with examples, right? Now before that, let us consider rho. It is the density of the body. Let us consider rho to be the density of the body. Clear students? And sigma. This is known as rho, RO, and this is the symbol for sigma, S-I-G-M-A. It's a notation used for density. So rho is the density of the body and sigma is, suppose, the density of the liquid in which the body is immersed. Right students? Here in this case, obviously the body sinks, therefore W must be greater than the upthrust. Here W must be greater than upthrust. This is the first case. Right? Body will sink only when the weight of the body is greater than the upthrust. That is, the weight of the body is greater than the weight of the liquid displaced by the submerged portion of the body. It is only then the body will sink. And in case, as I told you, if the body is not hollow from inside, then the density of the solid must be greater than the density of the liquid. So this situation is possible only when W is greater than U. Weight of the body is greater than the buoyant force. And in such a case, if the body is not hollow from inside, then the density of the material of the body is found to be greater than that of the density of the liquid. Right? It is the case of an iron nail. Iron nail in water. So what happens is, the density of iron is much more as compared to water. So it sinks. And the weight of the iron nail is less than the weight of the liquid displaced by the nail. So that is the reason why the iron nail sinks. This is the reason, right? Let's concentrate on this. The body floats on the surface of the liquid with some part immersed inside the liquid while some other part in air, right? This is possible only when the weight of the body is equal to upthrust, which in this case would be equal to weight of the liquid displaced by, not the entire body, by the submerged portion of the body, by the submerged portion of the body. So when this condition gets satisfied, then the body will float on the liquid. So for this to happen, the weight of the body must be exactly balanced by the weight of the liquid displaced by the submerged portion of the body. Clear students? So in this case, basically the density of the material of the body must be less than the density of the liquid. This is possible only when a solid body can float only when the density of the body is less than the density of the liquid on which it floats. Now what would be the example? Example is blocks of ice floating on water. That's an example. Right? So icebergs floating. This is an example. Icebergs floating on sea or oceans. That's an example. The density of ice is about 917 kg per meter cube, while the density of water, we are aware, it is about 1000 kg per meter cube. So you can notice the density of iceberg or the density of ice is less than the density of iceberg is less than the density of water. So as a result, it floats. Clear? So this is the condition which is satisfied. Okay, now let's consider the third case. Let's consider this case. It is possible again when weight of the body, which is the force of gravity, is exactly equal to upthrust. In this case, upthrust would be equal to the weight of the liquid displaced by the entire body. It is equal to the weight of the liquid displaced by the entire body, because all part of the body is immersed. And if the body is not hollow from inside, then the density rho must be exactly equal to sigma. That is, the density of the body must be exactly equal to the density of the liquid. It is only when this condition is satisfied that the body can float while totally submerged inside the liquid. Right? This is practically not possible for two different bodies. Why it is not possible? Because two different bodies are always having different densities. Two different bodies can't have same density, because density is the characteristic property of a body. It depends upon the nature of the material of the body, right? So this is practically not feasible. But still, there is an example. Example is olive oil. When it is placed on a mixture containing equal quantities of alcohol and water, then it remains in the standing position on the surface of that mixture. This condition is satisfied in that case. So olive oil placed on a mixture, and mixture of water and alcohol of equal quantities. So this is the example of this particular case, but it is not two different bodies. It is basically olive oil placed on a mixture of equal quantities of water and alcohol. In that case, the density of the olive oil is exactly equal to the density of this mixture. So this condition is satisfied, and accordingly this case arises. Right? So I hope you have understood this particular concept. Okay students, now let's consider the case when the body is not solid. It is hollow from inside. Right? Let's take the example of a ship or an empty sealed steel tank. Now students, there is a very interesting case. In such case, average density of the body is to be considered. Now look, ship, we are aware, ship is huge and it is made up of steel or iron, and the density of steel or iron is much greater as compared to the density of water. So density being greater, it should sink inside the water, isn't it? But most of the volume of this ship is hollow. It contains air. So the average density of the ship is found to be less than that of the density of water. So in such case, the average density is to be considered. What I mean is, students, in the case of ship, in case of a ship, the average density is to be considered, and it will be equal to mass divided by total volume of the ship. And as I have told you, students, the material with which ship is made, no doubt, is of steel or iron, but the maximum volume of the ship contains air, whose density is very, very low, right? So average density, in order to calculate average density of the ship, we will divide the entire mass of the ship with the total volume of the ship. This includes the huge volume of the air. So as a result, the average density of the ship is found to be less than the density of water. And as a result, the ship is able to float on water. Clear, students? Similarly, you can take the example of sealed steel tank. Now, this is a tank or a sealed steel can, right? The material of which it is made is of steel. Its density is large as compared to that of water, no doubt regarding this. But what happens is, it still floats. It is because it has volume. We need to consider the entire volume. And maximum volume of the steel can contains air. It contains air. So, if we find out the average density of this hollow body, it will be equal to mass over total volume of the steel can. And maximum volume of the steel can is filled with air, having very, very low density as compared to that of water. So, average density of the steel can as a whole, it becomes less than that of the density of water. And this is the reason why steel can is able to float on water. Right? Let me discuss another example, students. Have you seen hydrogen-filled balloon rising upwards? The reason being, hydrogen is the lightest gas. The density of hydrogen is less than that of air. So, this is a balloon. This is suppose a hydrogen balloon. This is suppose a hydrogen balloon and it is in air. It is in air. So, the density of hydrogen is very, very less as compared to density of air. So, what I mean to say is that it will be under the action of two forces. One is its weight, and air will exert an upward force on the balloon, and that is known as upthrust. Upthrust, students, depends upon the density of the fluid. In this case, the fluid is air. So, density of air being greater than that of the density of hydrogen, the upthrust would be greater than that of weight of the hydrogen balloon. So, in this case, U being greater than W, that is the buoyant force being greater than the force of gravity or the weight of the balloon rises upwards. It tends to rise. Clear, students? So this is the reason why hydrogen balloon tends to rise upwards. So these all are the applications of Archimedes Principle. So I am sure you are able to understand each and every minute details which are covered in this particular session, right? Hope you have enjoyed this session and do join me in my next lecture then. Till then, goodbye and do take very good care of yourself. Stay blessed always.